Number 9 is another problem in which it looks like we need to use u substitution, but in fact we don't. We see x squared minus 1 over x plus 1, but x squared minus 1 is a common binomial which we know factors to x plus 1 times x minus 1 through the difference of two squares. Well, now our x plus 1s are going to eliminate each other, so this is really just asking for the integral from 1 to 2 of x minus 1 dx. And again, the reason why, one thing we want to check out here is 1 to 2, we have an issue when x is equal to negative 1 in the original problem. Negative 1 is not part of our inside of our interval that we're interested in, so we don't have to worry about the fact that we just eliminated a 0 in the denominator. If this had said, say, negative 5 to 2, well, negative 1 is in between negative 5 and 2, and then we would have to alter our definite integral. But that's not the case here. Right. What we can do now is change x minus 1 into x squared over 2 minus x. That's being evaluated from 1 to 2. I'm going to plug the 2 in first. So we have 2 squared over 2 minus 2. And then we plug in the 1. So this is 4 over 2 minus 2. That's 0. Minus a half minus 1 is negative a half. 0 minus negative half, that's a double negative. This is a positive. Our answer is A. With number 10, we have the integral from 6 to 12 of f 2x dx is equal to 10. Which of the following must be true? Right, so we see in every single one of the cases we have this t instead of 2x. So it looks like we need to make t equal to 2x. If that's the case, dt is equal to 2 dx. In essence, we're doing u substitution, except we're using the variable t. So it's t substitution. It's the same process. Okay, so we can change this to f of t, but dt can only come in if there's a 2 dx. We have a 2 dx, but we're missing the 2. So 2 on the inside, 1/2 on the outside. Now dt can come into play. The bounds have to change. 6 and 12 both get doubled. So we have 12 and 24. And what we've done now is we've changed from x over to t. But this integral expression was equal to 10. So this new integral expression must also be equal to 10. Well, none of our expressions and their answers have a 1/2. So let's move that over to the other side. In doing so, we see that we have the integral from 12 to 24 of f of t dt is equal to 20, and that's answer B. And then with number 11, we have the integral from 2 to 4 of 1 over 5 minus 3x dx. Use substitution again. U is equal to 5 minus 3x. du is equal to negative 3 dx. We don't have the negative 3, so we're going to throw it in there. And the corresponding negative 1/3 out front. Now we can rewrite this. We have negative 1/3 antiderivative, du in the numerator, u in the denominator. We have to plug in the 2 and the 4. When we plug in 2, we have 5 minus 6, or negative 1. When we plug in the 4, 5 minus 12, or negative 7. Notice how you can start to see some of the numbers in our answers. Well, looking at this, negative 1 is larger than negative 7. We need to swap our bounds, which means we have to change the sign out front. The antiderivative of du over u is natural log. So we have 1/3 natural log of the absolute value of u being evaluated from negative 7 to negative 1. We plug the negative 1 in first, so we have 1/3 times the natural log of the absolute value of negative 1 minus 1/3 times the natural log of the absolute value of negative 7. The absolute value of negative 1 is 1. and the natural log of 1 is 0. The absolute value of negative 7 is 7, and there's no simplifying that. So we need the negative 1/3, the natural log of 7, which is b.